Hello, this is Helen Thomas and the CDFM study group. Today I'm going to continue review of CDFM Module 4, Competency 2, Systems Engineering. We're going to pick up on page 4.2.41, Important Design Consideration. So the last couple of videos we went through the various acquisition phases and milestone decision points and what happens at each and who is responsible for what, what's the purpose of the phase and so forth. So now we're going to look at some other important design considerations. So let's go to page 4243. Important design consideration, an open system design. What does that mean? An open system is a system that employs modular design tenets, uses widely supported and consensus-based standards for its key. All right, got a lot of going on there. So really, it's using widely specified supported items, meaning it doesn't have that unique part that only that company serves or only that system can use. It wants an open system design so you can take other parts, uses widely supported parts to make that product that you need. So DoD's acquisition system uses an open system design, widely supported and consensus-based standards. We don't want the standards to be so specific that we have to end up developing new products every single time we need something. All right. Interoperability, standardization. All right. Let's go to page 4245. At the bottom, commercial off-the-shelf items. Again, remember, it's an evolutionary acquisition process. So we either want the system to be open, where we have more choices, or we may be able to get a commercial product that's already out there, and maybe we just need to militarize it, right? Jazz it up for the military requirements. So use of commercial items that's already out there to make it, to reduce the time, because let's say we need a new Humvee to do what we need to do, and in the civilian sector they have a similar Humvee and we just need to tweak it a little bit to get the things that we needed to do. So commercial off the shelf item that's what it's saying. Maximum use of mature technology. The technology is already in use, it's already out there, so why not tap into it? So that's what commercial off the shelf items refer to. Manufacturing capability. All right, let's see. Your RAM on 4247, the program manager should establish a let's read that one. Reliability, availability, and maintainability. Again, when an open system, we also want where we easily can get the parts. Availability, you can maintain it easily. You don't have to have a subject matter expert every time you need to repair something. So the PM, again, program manager, must establish the RAM objectives in the acquisition cycle and address them as a design parameter within the acquisition process. So he builds it based on the ICD, Initial Capabilities Document, or the Capability Development Document. All right, so I'm just reading through for you. Reliability requirements address, okay, so here we go. Address mission reliability and logistics reliability. If we need parts for it, can we order it and get it right away? The former addresses the probability of carrying out a mission without a mission critical failure. Availability requirements. All right, so let me underline, hold on. So reliability requirements, it tells me what it addresses. So it addresses mission reliability and logistics. It's reliable. That means I can take it to war and I don't have to worry about it breaking down and now I have to contact the company back in the States, too much, doing too much. So availability requirements addresses the readiness of the system. All right, so I'm going to write that. Readiness. So is it available and ready? Readiness. Reliability, a work without failure, critical failure. Work without critical failure. All right. And the next one is maintainability requirement, addresses the ease of efficiency with which serving and preventive and corrective maintenance can be conducted. Ease and efficiency for maintenance. So ease of maintenance. All right, so got that. Supportability. The program manager should conduct supportability activities when using an evolutionary acquisition strategy. Supportability addresses performance and support requirements for both the total life cycle of the system and for each capability increment. Talks about human systems integration. We're going to integrate human, environment. We got to consider the environment, corrosion prevention. Those are pretty much easy to determine what they mean. Disposal and demilitarization, doing systems engineering as part of the program manager's total life cycle system management. I'm on page 4251. The program manager should consider material disposal and demilitarization. The PM shall coordinate with DoD components. Okay. All right, so we already know that. Information assurance, again, the PM should incorporate information assurance requirements. What are your IA requirements? Intensive munitions, anti-tamper-proof system. All right, so a lot of these is straightforward. All right, where do I want to go? Let's see. Accessibility, research and technology protection. Okay, yeah. All right, I'll leave that. Okay, I see some highlights over here. Page 56, 4256 says that I need to go over. Remember, this is the same systems engineering plan that we talked about earlier. So we're going to go into it in a little bit more detail. The one that we have, one in milestone A and one in milestone B. The PM shall prepare a systems engineering plan for each milestone review, beginning with milestone A. At milestone A, the SEP shall support the technology development strategy at milestone. So it's repeating what we already said earlier. And milestone B, the SEP shall support the acquisition strategy. The SEP shall describe the program's overall technical approach. So engineering plan. Engineer is technical. So technical approach. So I'm just writing that in my book. So when I come through the study guide again, it won't be as difficult. This is my first time actually reading through the study guide. All right. Page 4257 at the bottom, modeling and simulation. Let's see, why do I have some highlighted? The next page, 58 at the top. Modeling and simulation is an essential element of the systems engineering process. It can represent the system of systems environment as a context of systems and engineering. So I was going over page 4258 at the top. Modeling and simulation is an essential element of the systems engineering process. Modeling and simulation can represent the systems of systems, the cost and complexity of modern weapon systems, particularly within a family, preclude the development of full-scale prototype. Similarly, the cost of testing events limits the number of tests that can be practically conducted. Modeling and simulation supports the engineering decision process by supporting system design, trade studies, financial analysis, sustainment. All right. So modeling, where my pen go? All right, we'll go with this. Modeling and simulation occurs in the system, the engineering, manufacturing, development process. Thank you. All right, summary of technical reviews. So you have all the different technical reviews that occurs. Initial technical review, alternative, systems requirements, preliminary. All right, looks good. Website, system engineering resources. All right, I got some highlighted here. So the 5 phases. So the 5 phases, let's see if I can do them. Material solution analysis. Then you have milestone A. Then the purpose of milestone A is to do the analysis of the alternative. Then you get approval for technology development. The purpose of technology development is to reduce technology risk. Then once it's approved, you move to milestone B. Milestone B is a spot where you have program initiation for the acquisition process, acquisition strategy. In milestone A, you have a system engineering plan, a SEP. And in milestone B, you have a SEP that meets the acquisition strategy. In milestone B, you also annotate the LRIP, low rate integration, low rate initial production numbers, the quantity that you're going to produce. Then engineering and manufacturing phase, production and deployments, operation and support. So in milestone C is when you go into that developing the LRIP, that low rate number. And then if they like what they see, then they request the full rate initial capability. And then from there, you go to the operation. Once you deploy the items, you go into operation and support, and you make sure that you have an open system so that it is sustainability. Let me see the RAM, reliability. Ooh, I gotta look back. Reliable. What's the A? Brain cramp. Sustainable. All right, so I'm flashing back to page, the RAM, where it says research departments, the survivability, reliable, available. Okay. Reliability, meaning it's reliable so that if I deploy with it, it's not going to have any critical failures. It's available, so it meets readiness because the item is available. Maintainable, meaning it's ease for maintenance. So the RAM, RAM. All right, so I got that. What else? Milestone. All right, so what is all this that I have on 63? So page 4263, I have that I need to review that figure 1, requirements for milestone and decision. Because what I understand from this exam is we need to be able to determine if they say analysis of the alternative study guidance. I need to know that this occurs in the milestone decision, at the end of the milestone decision material solution analysis phase. So that's your MDD document, decision review. So that happens before milestone A. So you're going to need to be able to say, did it happen before milestone A, at milestone A, before milestone B? Where does it happen? Is it technology development? Is it engineering and manufacturing, production and deployment? Okay, so I need to review. So make sure you review. So everything. So what this chart then tells me, it has everything from this whole first part that we covered, that everything is listed here. And then you need to be able to say, is it milestone decision point? Is it milestone A, B, production and deployment, engineering, milestone C, full rate capability, what's going on? So that's what I got from there. All right, summary. Throughout all phases of the system life cycle, the systems engineering process employs a variety of techniques and tools of management, oversight, and analysis. They are applied iteratively and to some degree occur in all phases of the system life cycle. Key among them are the systems engineering plan, the integrated master plan, the master's schedule, value engineering, technical performance, measurement. All right. Your team is, let's see. Okay, that's practical exercise. So this part then, page 4263, completes CDFM Module 4, Competency 2. So I stopped or began on page 41 and ended on page 64. All right, so be sure to subscribe to my YouTube channel and share my YouTube page with all those. Again, it's no cost to you. So be sure to share the page with others that are studying to be CDFM certified, and also to add the acquisition to the back of that certification. So thank you again for stopping by, and I'll see you guys again next time.